Hi friends, we are discussing rotational motion of the particle and rigid body. Introductory part, or we have discussed center of mass also. Once again I repeat definition of center of mass. Center of mass is defined as a point where whole mass of a body is supposed to be concentrated in order to study its motion under the action of force in accordance with Newton's laws of motion. This becomes a precise definition of this center of mass. While studying this rotational motion, we come across vector product and scalar product. Both these vector product of vectors and scalar product of vector we have already studied in previous chapters, and we all know what are the scalar products of two vectors and what is a vector product. Now once again I take one example for that one, and which is given in book. It's a solved example, that is 7.4. There is find the scalar product and vector product of two vectors. A is equal to, A is given there, it is 3i minus 4j plus 5t. A is given 3i minus 4j plus 5t. B is equal to minus 2i plus j minus 3. Minus 2i plus j minus 3t, etc. Now scalar product and vector product is asked. Let us see. Generally the vector, any vector A, vector A is represented as axi ayj plus azk. Ax, that is, these are coordinates az. For example, in this one coordinates are minus 4, 5. X, y and z coordinates, these are known as x, y and z coordinates. Similarly, there is, suppose that this is now A, this is B, or I make it, this is small a I take. Similarly, small b is equal to bxi plus byj plus bzk. Then bx, by, bz, these are coordinates. From this one we can get it minus 2 plus 1 minus 3. So we got it ax, ay, az. By comparing it, we can write ax is equal to 3, ay is equal to minus 1, ay is equal to minus 4, az is equal to 5. Ax is equal to 3, ay is equal to minus 4, az is equal to 5. Similarly, bx is equal to minus 2, by is equal to 1, bz is equal to minus 3. Then a dot b, scalar product, it's a dot b is equal to ax bx plus ay by plus az bz. Tell me, how much is ax? Ax is equal to 3 into minus 2. This 2 plus minus 4 into 1 plus 5 into minus 3, which is equal to minus 6, minus 4, minus 15, which becomes minus 24. A dot B. If negative, it means that angle is obtuse, greater than 90. We all know. By definition, this is equal to AB cos theta. If this is negative, it means that cos theta is negative, theta greater than 90. So this is the scalar product of these two vectors. Similarly, vector product of A cross B. A cross B is given as I, J, K, AX, AY, AZ, BX, BY, BZ, which is equal to this one, I, J, K, AX, 3 minus 4, 5, 3 minus 4, 5, BX, minus 2, 1 minus 3, which is equal to I. We solve this thing. From here to here we know. Product of this two, 12. Minus product of this two, 5. Middle side is taken minus. This we block. That case, this we block and we take this product first. Minus 9. It is minus 9. Minus 10 will become plus 2. Then last one, it is plus. This we block. 3 minus 8. Altogether it becomes 7I. This is minus 3 because 1. This is 7, 1 minus 5 minus 5 A cross B is equal to 7I minus J plus minus J minus 5K. Here it is taken as, it should be minus 5K. Last step in book is wrong. Last step, whatever book I have, it's a printing mistake. Actually this is minus 5K is right. That's all for scalar product and vector product. One more point I would like to say about this vector product. We have already discussed its properties. But vector product, reflection symmetry. What is the meaning of reflection symmetry? That we will see there. So properties of this scalar product, we say. Properties of vector product, we say. That is, A cross B is not equal to B cross A. It's not a commutative. We change the direction. They are not equal. In fact, A cross B is equal to minus B cross A. What does it mean? This is the vector A. This is the vector B. It's rotated from here to here. Then A cross B is a vector C. What is A cross B? It's a vector C. And then, which is having magnitude AB sin theta. Which is having magnitude AB sin theta. And its direction is perpendicular to both A and B. And in a sense, right hand would advance when rotated from first vector to second vector. When we are rotating it from first to second vector, A to B, the right hand screw will advance in upward direction. So C is equal to A cross B. But when we come B cross C, the right hand will go in this direction, that becomes B cross E. It simply indicates A cross B is equal to minus B cross E. It also obeys distributive property. But reflection symmetry. What is the meaning of reflection symmetry? Meaning of reflection symmetry, let us see. Suppose that A is equal to AXI plus AYJ plus AZK. I replace all this. AX I replace by minus AX. BX I replace by minus BX. And BZ I replace by minus BZ. Then there is B is equal to Bxi plus Byj. B is equal to, here B is equal to Bxi plus Byj plus Bzt. So A became minus A, A became minus A, B became minus B, and then A cross B is equal to minus A cross minus B, which one will be A cross B. So minus A cross minus B, if it is equal to A cross B, it means that the vector product is having reflection symmetry. So this is the meaning of reflection symmetry. They are having reflection symmetry. This is the only extra property discussed in this topic. Otherwise, remaining properties we have discussed in previous chapter. That's all for this. Thank you.